All right, so in this review, we're going to look at rationalizing denominators. So let's look at this first example to begin with. So number one, let's suppose we have 5 divided by the square root of 3. Now notice the denominator is an irrational number. The square root of 3 is irrational. So we need to rationalize that. We need to make it a rational number. The easiest way to do that, and there are multiple ways to make this a rational number, but the easiest way, since this is a square root, is to multiply both numerator and denominator by the square root of 3. All right, and that will rationalize that denominator. That will make this denominator a rational number. So remember, what you do to the numerator, you do to the denominator. So that's why you see square root of 3 divided by square root of 3. Because remember, that's still 1, right? So 5 divided by the square root of 3 times 1, anything divided by itself of 1 gives us this back. So what we end up with is this. Now we have 5 square root of 3 divided by, and then almost all of you know that the square root of 3 times the square root of 3 is 3, right? If you wanted to write this as square root of 9, you can, but I need for you to simplify this. So we get 5 square root of 3 divided by 3. And notice 3 is now a rational number. So we rationalize the denominator. All right, so it's a pretty easy process to rationalize the denominator. So remember, rationalizing the denominator means that if it's irrational, you want to make it a rational number. All right, so number 2. And that's a process you go through. So let's get number 2. Number 2, let's suppose we have the square root of 8 divided by 5. 8 divided by 5. All right, now this looks a little bit different than the number 1, because notice that this says square root of 8 divided by 5, but you've learned, you know something about the quotient rule for radicals. So you know that according to the quotient rule, I can rewrite this as the square root of 8 divided by the square root of 5, right? And then let's go ahead and rationalize that denominator. So I'm going to multiply both numerator and denominator by the square root of 5. All right, so that statement is still a true statement. These are still equal to each other, because remember, this is still 1, and 1 times this is this right here. So now I get this. Now remember, we're going to use the product rule now. So remember, when you multiply radicals and the indices are the same, square root, you can multiply the radicands together. So this is the square root of 40 divided by, and then the square root of 5 times the square root of 5 is the square root of 25, which is just 5. All right, now, one other thing you got to remember is that you need to simplify any radicals if possible. So you see the square root of 40? You have to ask yourself, is there a perfect square that goes into 40? And let's use the largest. So if you notice, 4 is the largest perfect square that goes into 40. So I can rewrite this as the square root of 4 times the square root of 10, and the square root of 4 is 2, so you get 2 square root of 10. So that's the numerator, so I get 2 square root of 10 divided by 5. All right, but notice that the goal was to make to make the denominator a rational number, and the denominator is a rational number. 5 is a rational number. But also remember, you need to simplify radicals if possible. All right, so that's number 2. Let's look at number 3. In number 3, we have 3 square root of 6 divided by the square root of 10. All right, so notice the square root of 10, the denominator, is an irrational number. So I want to make it a rational number. So the process, notice the process is, and I'm going to go ahead and rewrite this over. So the process to make the square root of 10 a rational number is to multiply the square root of 10 by itself. That's the easiest way to do that. So I'm going to multiply both numerator and denominator by the square root of 10. And so using the properties we just talked about, the square root of 6 times the square root of 10, that's going to be the square root of 60. Since we're dealing with square roots, the indices are the same, then we can multiply the radicands. And then the square root of 10 times the square root of 10 is the square root of 100, and that's just 10, right? Okay, now you need to reduce. First of all, you cannot reduce the 3 and the 10, but if you could, you would. And then the square root of 60, you need to ask yourself, is there a perfect square that goes into 60? All right, so for example, let's see if 4 goes into 60. So 60 divided by 4, and we get 15. So 4 is a perfect square that goes into 60 and is the largest because 15, the only perfect square that goes into 15 is 1. So let's go ahead and talk about that. Square root is 60. So the square root of 60 will be the square root of 4 times the square root of 15, and the square root of 4 is 2. So you get 2 square root of 15. All right, now listen carefully to this. So we have this, right? So we know we have to simplify the radicals. So I get 3 times this right here is this. So make sure you write that out. It helps to write that out. Over 10 divided by 10. 3 times 2 is 6. So I get 6 square root of 15 divided by 10, and then reduce. See, if you leave it like this, you're not going to get full points. You did quite a bit of work, and that's pretty good with the work you do. But remember, you need to reduce if possible. So 6 and 10 are both divisible by 2. So when you look at that, 6 divided by 2 is 3, 10 divided by 2 is 5, and so you get 3 square root of 15 divided by 5. And there's your answer. Now, one remark I got to make is that some students make the horrible mistake of reducing the 5 into 15. You cannot do that because that is not 15. That's the square root of 15, right? So the square root of 15 and the square root of 15, if you look at it right here, is not divisible by 5. So you got to be careful. Watch. Square root of 15, see this? Is this. That's not divisible by 5. All right, so you have to be careful. All right, so if that was just 15, then yes, you could reduce. But that's not 15, that's the square root of 15. So be very careful. Think about what you're dealing with. All right, so that was number 3. Let's go to number 4. So it's not a difficult process, fairly simple to deal with. So number 4, we have 9 divided by the square root of 12. All right. Now, what some students will do is they'll see the square root of 12 and they'll say, well, I can simplify the square root of 12 right away. And you could. But what I would do is I would just go ahead and first of all, rationalize the denominator. Let's do that first. So let me go ahead and rewrite this over. And so when I rationalize the denominator, I'm going to multiply both numerator and denominator by the square root of 12. That's the process we've been dealing with, right? And so I get 9 square root of 12 divided by, remember, the square root of 12 times the square root of 12 is just 12, right? It's just the square root of 144, which is 12. All right, now, so some of you may say, well, can I reduce the 9/12 right now? Yeah, you can. You can do that if you want to. So let's see. So you're going to get 9 divided by 3 is 3. 12 divided by 3 is 4. So you get 3 square root of 12 divided by 4. Okay? But remember, that's not the answer because you all know you can simplify the square root of 12 because the largest perfect square that goes into 12 is 4. So if you think about the square root of 12, that will be the square root of 4 times the square root of 3, which is 2 square root of 3. All right, so now notice what happens. I have 3 times the square root of 12 is this. So 2 square root of 3 divided by 4, right? And 3 times 2 is 6, so I get 6 square root of 3 divided by 4. And now we can reduce again, couldn't we? So these are both divisible by 2. So let me go ahead and rewrite this over. So they're both divisible by 2. So 6 divided by 2 is 3. 4 divided by 2 is 2. And so your answer is 3 square root of 3 divided by 2. Okay? So notice first of all that my answer, the denominator is a rational number. So hence the idea, you want to rationalize the denominator. Secondly, notice through the process, I simplified radicals and I reduced whenever possible. Now, I want to say this. Remember a while ago we said that some of you may have recognized you could simplify the square root of 12. And remember, the square root of 12 is this, right? So let me show you something. So let me go ahead and do it on another sheet of paper. So let me show you what some of you could have done as well. Now, this is what most students will do, and that's great. That's perfectly fine. But here's what someone else could have done. So they could have said, well, I'm going to go ahead and simplify the square root of 12, which we know is 2 square root of 3. So this becomes 9 divided by 2 square root of 3, right? And that's true. The square root of 12 is this. It's 2 square root of 3. And so here's what you could have done. You could have said, All right, I have the square root of 3. I want to make that square root of 3 a rational number. So you could at that point multiply both numerator and denominator by square root of 3, couldn't you? And notice what's going to happen. Watch. Very simple. 9 square root of 3 divided by 2. And then the square root of 3 times the square root of 3, I'll go ahead and write it out, is the square root of 9, isn't it? But I'm going to ask you, what is the square root of 9? Well, the square root of 9 is 3. So that's 9 square root of 3 divided by 2 times 3, right? 2 times 3 is 6. So that's 9 square root of 3 divided by 6. And then reduce. The 9, 6 are both divisible by 3. So that's 2, that's 3. And you get 3 square root of 3 divided by 2. And that's the answer you got in it. Okay? So you see, if you want to, you could reduce. I'm sorry, you could simplify the denominator before you rationalize. You could still get the same answer. Now, some of you may say, well, you multiplied numerator and denominator by the square root of 3. Could you have multiplied numerator and denominator by 2 square root of 3, the denominator? Sure you can. What would have happened? So there are multiple processes, right? So you get 9 divided by 2 square root of 3. All right, so here's what some of you would have said at that point right here. Let me go ahead and rewrite this over. Okay, so remember the idea is to get rid of that square root that's in the denominator. And so that's why I just multiplied numerator and the denominator by the square root of 3. But some of you could have said, well, I'm just going to multiply numerator and denominator by the denominator, 2 square root of 3. And that's perfectly fine. You can do that. 9 times 2 is 18. Square root of 3, so that's a numerator, right? The denominator, now be careful. You have 2 times 2 is 4 now, right? 2 times 2, so that's 4. 4 times. And then the square root of 3 times the square root of 3 is the square root of 9, which is 3. So you get 4 times 3. So this becomes 8 square root of 3 divided by 12, and then reduce. So we're getting to that point right here. 18 and 12 are both 18 and 12 are both divisible by 6, right? They're both divisible by 6. So 18 divided by 6, 18 divided by 6 is 3. 12 divided by 6 is 2. And you get 3 square root of 3 divided by 2. So same answer, right? Different approaches. Okay, so that was number 4. Now look at number 5. So number 5, we have the square root of 3x divided by the square root of y. Okay? And so this time we have a variable. It's okay. I want to get rid of that square root. So if I'm going to, the idea that we dealt with in the previous 4 problems was to get rid of that square root that's in the denominator. So the square root of y, if I want to get rid of that square root, then I'm going to multiply both numerator. Let me go ahead and rewrite this over. I'm going to multiply both numerator and denominator by the square root of y. That's the process we've been using. And so you got to remember the product property. So since the indices are the same, they're both square roots, I can multiply the radicands together. So that'll be the square root of 3xy divided by, and remember the square root of y times the square root of y is just y. Just like the square root of 3 times the square root of 3 was just 3, right? So if you, for some of you though, you may say, well, I'm going to go ahead and multiply y and y together. All right, that's fine. That's the square root of y squared. But now you know that the square root of y squared is just y. 2 divided by 2 is 1. So you get the square root of 3xy. Make sure you extend that symbol, divided by y. And there's your answer. Okay, that's all you do. Notice I got rid of that square root that was in the denominator. Number 6, we have the square root of 12x to the 4th divided by the square root of 6. All right, square root of 12x to the 4th divided by the square root of 6. And so what some of you, and remember, just like we did with number 4, where we had different processes, different approaches, you could do the same thing here. Some of you may say, well, I'm gonna simplify the numerator first, because I know what the square root of x to the 4th is. That's x squared. That's true. And I know I can simplify the square root of 12. We already talked about that. That's 2 square root of 3. That's true as well. All right. I'm going to go ahead, though, and just rationalize the denominator right away. And so So I'm going to get, let me go ahead and rewrite this over. So I get 12x to the fourth. Make sure you extend this because x to the fourth is under the square root divided by the square root of 6. I'm going to multiply both numerator and denominator by the square root of 6. By doing that, the square root of 6 and square root of 6 is 6. That rationalizes that denominator. That square root is no longer, the radical is no longer there. That square root is no longer there. But here's the problem now. I have to multiply these two radicals together, these two square roots. So 12 times 6, 12 times 6, use your calculator if you have to. 12 times 6 is 72. So I get the square root of 72 x to the fourth. Okay? Now, you got to simplify this if possible. So let's talk about the square root of 72. I'm going to go off right here and do that. Square root of 72. Well, the largest perfect square that goes into 72 is 36, isn't it? So that's the square root of 36 times the square root of 2. And the square root of 36 is 6, so you get 6 square root of 2, right? Now let's talk about this. Well, let me go ahead and remind you about this. So remember, many of you will do this. You'll say, well, that'll be the square root of 72 times the square root of x to the fourth divided by 6. All right. And then so the square root of 72 is this. Now, you all know the square root of x to the fourth. That's an easy one. What times itself is x to the fourth? Well, it's x squared. And the other approach you took was you said 4 divided by 2 is 2. So what this becomes is 6 square root, let me go ahead and rewrite this over, 6 square root of 2 times x squared, right, divided by 6. Now look how simple this is now. The 6's divide out, right, and so I get the square root of 2 times x squared. Now be careful, and some of you get yourselves into trouble because you when you write it, you extend this to where it looks like that x squared is under the square root. The x squared is not supposed to be under the square root. That factor is not supposed to be under the square root. So you got to be careful. So make sure you you're able to distinguish when it's under the square root and when it's not. All right. So what most students will do, so that way they don't get themselves into trouble, is they'll put the square root on the end. So they'll write it as x squared times the square root of 2. Okay? Let me go ahead and do that same problem just to show you. Let me go ahead and do that same problem right here. And I want to just show you this. So some of you may have wanted to simplify the numerator first, and that's definitely fine. So that would have been the square root of 12 times the square root of x to the fourth divided by the square root of 6, right? And the square root of 12 we know is 2 square root of 3. The square root of x to the fourth we know is x squared divided by the square root of 6, right? Now at that point, you may want to go ahead and rationalize that denominator. So you're going to get 2 square root of 3 times x squared divided by the square root of 6. So you multiply both numerator and denominator by the square root of 6. The denominator is easy. The square root of 6 times the square root of 6 is 6. Now you have to be careful. You got to remember that the square root of 3 times the square root of 6 I can write as one square root. So I get 2x squared times the square root of 18, right? 3 times 6 is 18. And then you got to go back now and you got to figure out, well, I can simplify the square root of 18. The largest perfect square that goes into 18 is 9, so it'll be the square root of 9 times the square root of 2. The square root of 9 is 3, so you get 3 square root of 2. So here's what I have. I have 2 times x squared. The square root of 18 is this, so 3 square root of 2 divided by 6. Now I want you to notice something. So if you reduce, 2 times 3 is 6, right? And then that 6 divides into that 6. Some of you could have done this. You could have said 2 into 2 is 1, 2 into 6 is 3, 3 into 3 is 1, 3 into 3 is 1, right? And so you get 1 times x squared times 1 times square root of 2. So you get x squared, square root of 2 divided by 1, which is just this. So notice different approaches you can use. All right. So it looks like this one though was fairly much simpler approach than this one. Okay. All right. But just to let you know, there are different approaches you can take. All right, let's look at number 7. All right, number 7. So let's do a few more. So number 7. So number 7, we have this. We have so we have 4 divided by 6 square root of 5x. All right. And you remember a while ago we looked at this problem, if I can find it real quickly. We looked at this right here. So remember we saw another approach we could take, and then since I just wanted to get rid of that square root symbol, I just multiplied both numerator and denominator by that square root. That's the approach we're going to take here. So rather than multiplying both numerator and denominator by this denominator, let's just multiply by the square root. All right, so we're going to get, I'm just going to go ahead and rewrite this over. So I'm going to multiply both numerator and denominator by the square root of 5x. All right, square root of 5x, just like this. All right, now, so now I'm going to write this as one fraction. So I get 4 square root of 5x, right? Divided by 6 times, all right, now we got to remember, you see this square root of 5x times the square root of 5x? You have to know that right off the bat, that's just 5x, right? That's just 5x. So you got to remember this. You got to remember the square root of 5x times the square root of 5x. Do y'all agree that's the same thing as saying square root of 5x squared? And then the square root and the square undo each other, so you're just left with 5x. That's one way. The other way is to actually multiply the radicand, so you get the square root of 25x squared. 5 times 5 is 25. X times x is x squared. The square root of 25 is 5. The square root of x squared is x. All right. So whenever you're dealing with square roots and the radicands are the same, when you multiply those, it's just that radicand. All right. Now let's go ahead and reduce. So you see this 4 and the 6, I can reduce that. So let's go ahead and do that now. So 6 times 5x. So 4 divided by 2 is 6. 4 divided by 2 is 2. 6 divided by 2 is 3. And that's about all I can do. So I'm going to get 2 square root of 5x divided by, and then 3 times 5 is 15. So you got to say that, 15x. And that's it. Now again, don't make the mistake and reduce the 5 into 15, because you know that's not a 5. That's the square root of 5. And the same thing here. That's not an x. That's a square root of x. So you're done. You're done. So that's number 7. So it's very simple process, isn't it? Okay, let's look at number 8. In number 8, let's suppose we had the square root of a divided by 100b. A divided by 100b. Now, I'm going to say this. Sometimes, if you look at this, first of all, let's go ahead and rewrite this as the square root of a divided by the square root of 100b. I just want to show you something. And there are different approaches you can take. Most of you will recognize, all of you recognize, that the square root of 100 is 10. So one approach I can take is that I'm going to rewrite this as the square root of a divided by 10 square root of b. And that's definitely correct. You can do that. And then just like we did here in the previous problem, I'm just going to go ahead and multiply numerator and denominator by the square root of 5x. Here I'm just going to multiply by square root of b. So let me go ahead and write this over. And so I'm going to say square root of b, and then write it as one fraction. The square root of a times the square root of b is the square root of ab, divided by, and then 10. And remember, the square root of b times the square root of b is just b. And there is your answer, right? Okay. Now, if for some reason you did not see that the square root of 100 was 10, then here's what you would have had to do. So you would have said the square root of a divided by the square root of 100b, right? So you would have had to go ahead and multiply both numerator and the denominator by the denominator to get rid of that square root. So you would have had this, okay? All right, and so now the numerator, when I write this as one fraction, since the indices are the same, we're dealing with square roots, I can write this as the square root of 100 ab, just like that, divided by, and then the square root of 100b times the square root of 100b is just 100b. And now you gotta simplify if possible. You all know, and you have to recognize this now. So that's why it would have been easier to recognize it here, that the square root of 100 is 10. So this becomes 10 square root of AB divided by 100B. And now I can reduce the 10 and the 100. 10 and 10 is 1. 10 and 100 is 10. So I get the square root of AB divided by 10B. All right, different approaches, different approaches. All right, so that's number 8. Let's look at number 10. So it's not that difficult, is it? It's a very simple process. Very simple process. All right, so let's look at number 9. All right, number 9, we have the square root of 98 divided by the square root of y to the 7th. Okay? And again, and there are multiple approaches you can take, but the easiest thing to do with this, to get rid of that square root, is just multiply numerator and denominator by that square root. That's the easiest thing to do. So let's do that. Let's do that. So I get square root of 98 divided by the square root of y to the 7th. So I'm going to multiply both numerator and denominator by that denominator. And so now notice the square root of 7, the square root of y to the 7th times the square root of y to the 7th is just y to the 7th, right? Now remember though, what's really happening. You have the square root of y to the 7th times the square root of y to the 7, don't you? And then remember, the indices are the same, so you can multiply the radicands. When you multiply like bases, you add exponents. So this really becomes the square root of y to the 14th. And then I can simplify this very easily because 14 is divisible by the index, which is 2. So that's y to the 7th. Kind of makes sense because y to the 7 times itself is y to the 14th. All right, so that's y to the 7th down here. And then the numerator becomes this. The numerator becomes the square root of 98 times the square root of y to the 7th. And I'm going to leave it like that for right now so we can have a discussion. Okay, so let's go ahead and see if we could simplify the square root of 98. Is there a perfect square? So let's talk about the square root of 98. Is there a perfect square that goes into 98 other than 1? So let's see if 4. So 98 divided by 4 does not. See, that's a decimal. So let's try 9. 98 divided by 9. Nope, does not work, right? So let's try, the next one will be what? Well, obviously 25 wouldn't go into it. So let's try 16 though. 98 divided by 16. Nope, that doesn't work. So let's try 49. 98 divided by 49. Yep, that's it. So 49. So square root of 98 will be the square root of 49 times the square root of 2. So that's 7 square root of 2. So that's going to go here. So this becomes 7 square root of 2 times, now let's talk about the square root of y to the 7th, because I know we know we can simplify that, so simplify if you can. All right, so remember all that. So let's talk about this, the square root of y to the 7th. So remember right here, the square root of y to the 14th, that was easy because 14 is divisible by 2. Remember when we talked about this in previous lessons, 7 is not divisible by 2, but I can simplify it because the exponent is larger, greater than or equal to the index. So was the largest whole number less than 7 that's divisible by 2? Remember that? So that's 6, right? So the square root of y to the 6 times the square root of y. And then the square root of y to the 6 is y cubed. So I get y cubed square root of y. And that goes here. So I get times y cubed square root of y, all divided by y to the 7th. All right, now I know it looks pretty complicated, but you got to remember all the information that you learned, all the skills that you learned. You know you can simplify y cubed and y to the 7th. You have 3 factors of y in the numerator. You have 7 factors of y in the denominator. All right, so you know you can simplify that. You can reduce that. Before I do that though, let's go ahead and write the square root of 2 and the square root of y as one square root. So it becomes 7 square root of 2y times y to the 3rd power divided by y to the 7th. Now let's go ahead and reduce these two. So I have 3 factors of y in the numerator, 7 in the denominator. So all of these will divide into the numerator, and then the 3 factors here, when I reduce it into the 7 I had here, I'll have 4 left. And so therefore the answer will be 7 square root of 2y divided by y to the fourth. All right. And so that's the process. Some of these is not as easy as others, but that's what you have to go through. Now let me kind of go back to number 9 and show you something else you could have done. So the square root of 98 divided by the square root of y to the 7th. Here's what some students will recognize. So you remember right here, where my index is 2, right? And so if the exponent's even, then that's an easy process to simplify, isn't it? So I want you to think about this. My index is 2. 7 is not divisible by 2. But what's the next even integer that's divisible by 2? It's 8, right? You'll agree it's 8? So isn't it true, I'm going to rewrite this over to show you what I'm talking about. Isn't it true that if I multiply the denominator by the square root of y, this becomes the square root of y to the 8th, right? 7 plus 1 is 8. And then the square root of 8 is just y to the 4th. And hey, look, isn't that what we got right here? See that? Now you just got to go ahead now and fix all these numerators, but that's the approach you would use, right? And so notice that when for this one, when I rationalize the denominator, I multiply both numerator and denominator the square root by the denominator. I didn't have to do that here because right away I just multiplied the denominator by some radical that will make the exponent even. Now I still have to multiply numerator and the denominator by square root of y. All right, I still have to do that, but notice I didn't multiply by the denominator, the original denominator. So now remember the square root of 98? Square root of 98, remember, is the square root of square root of 49 times the square root of 2. So that's 7 square root of 2. So that's going to go here. So I get 7 square root of 2 times the square root of y, right? But don't leave it like this because you know you can write this as one square root. So you get 7 square root of 2y divided by y to the 4th. And the same thing we got here. Different approaches you can take. All right, let's look at the next one. So let's do a couple more. So I think that will help you with the topic for this week on that part. So this is number 10. So number 10, let's do another one like that, see what happens. So number 10, we have the square root of 48 x to the 5th divided by y to the 3rd. Okay, so right away, let's go ahead and rewrite this as two square roots. So that will be the square root of 48 x to the 5th divided by the square root of y to the 3rd. Now let's think about that second approach we just did. So you see that y to the 3rd, and if this was a 4, then that'll be an easy thing, wouldn't it? So let's think about that. What can I multiply? Let me go ahead and rewrite this over. So what could I multiply the square root of y to the 3rd by, so that way this is the square root of y to the 4th? Okay, right, so the square root of y. That's what you would do. And so now this becomes the denominator. Look at the denominator. Y to the 3rd times y is y to the 4th, so it'll be the square root of y to the 4th. The numerator is the square root of 48 x to the 5th, y, right? Okay, now we got to simplify as much of this as possible. I now know that the square root of y to the 4th is y squared. So that's my denominator. So that's easy. But let's look at the numerator. So remember, the numerator is what we have here. So you got to simplify this as much as you can. Okay, so remember there was some lessons previously a while back in which you had to simplify something like this. So you said, well, that's be the square root of 48 times the square root of x to the 5th times the square root of y, using a product property. And the largest perfect square that goes into 48 is 16. So 48 divided by 16 will give you 3, right? So I get the square root of 16 times times the square root of 3. And remember how to simplify this. So the square root of x to the fifth was the largest whole number less than 5 that's divisible by 2. So you said x to the fourth times the square root of x. So that the square root of x to the fourth times the square root of x to the square root of x to the fifth times the square root of y. And then you simplify it. Square root of 16 is 4. So I get 4 square root of 3. Square root of x to the fourth is x squared. Square root of x, square root of y. And then remember, you got to write all these as one square root. So this is 4x squared times the square root of 3xy. So that's your numerator. 4x squared square root of 3xy. Okay? And that's that one approach. So the one approach is to think about what could you multiply this by, so that way that exponent is divisible by the index 2. The other way is just to multiply both numerator and denominator by the denominator in it. So let's do that. So let's do that same problem, but use a different approach. So number 10, just to show you're going to get that same answer. And by the way, there's nothing you could have reduced here, so that's why I didn't reduce. Okay, number 10, do the same problem over. You have the square root of 48 x to the fifth divided by y cubed. And so using the quotient property, I know I can write this as the square root of 48 x to the fifth divided by the square root of y cubed. And at that point, that's where you would just go ahead and multiply both numerator and denominator by the denominator, right? And that's fine. That's perfectly fine. You can do that. And so now the numerator will become, so if I write this as one square root, so it'll be the square root of 48 x to the fifth, y to the third. And then we now know that the square root of y to the third times the square root of y to the third is y to the third. Okay? Now notice, though, that's not the answer, because this is the answer you're supposed to get. So you got to simplify the numerator now. So go off to the side, just like we did before. Rewrite the numerator over, just like we did. Oops, that's a y cubed. And then you're going to use the product property. So it'll be the square root of 48 times the square root of x to the fifth times the square root of y cubed, right? And then for the square root of 48, we just saw that 16 was the largest perfect square that goes into 48. So I get the square root of 16, square root of 3. And then the largest whole number less than 5 that's divisible by 2 is 4. So it'll be the square root of x to the fourth, square root of x. And then for y cubed, that will be 2. So the square root of y squared times the square root of y. And then we know we can simplify this, and this, right? And so the square root of 16 is 4. Square root of 3, square root of x to the fourth is x squared, square root of x, square root of y squared is y, square root of y. And so I'm going to put these three as one square root. So I get 4x squared y, square root of 3xy, 3xy. And that goes in the numerator now, right? So I get 4x squared y, square root of 3xy, all divided by y cubed. Now, remember, I have a factor of y here and 3 here, right? So let me go ahead and rewrite this so I can write on it. So 4x squared y, square root of 3xy, divided by y cubed. So this factor will reduce with itself, and this fact that y, so I'm going to divide both by y, right? And so I had 3 here, so now I have 2 left. And so I get 4x squared, square root of 3xy, divided by y squared. And that's it. So same answer, different approach. Okay, let's do one more. So one more, and let's look at this one. So let's look at number, this was what, number 11? So let's look at number 11. So in number 11, we have negative 6 divided by the square root of 3x to the fifth. All right, so again, what many students will do is they'll see that square root, and then they'll just say, well, I'm gonna get rid of that square root by just multiplying both numerator and denominator by that denominator. And that's definitely true. You can definitely do that. And that's what most students would do. That's probably what I would do. All right, and so now And so now notice the square root of x to the fifth times the square root of x to the fifth, I'm sorry, 3x to the fifth times the square root of 3x to the fifth is 3x to the fifth, right? The numerator, though, is negative 6 square root of 3x to the fifth. But you got to simplify this, and you also notice you can reduce the negative 6 into 3. That's an x right here. So let's talk about the square root of 3x to the fifth. So let's talk about simplifying that. So using a product property, I know that that's the square root of 3 times the square root of x to the fifth. And I know that the largest whole number less than 5 that's divisible by 2 is 4. So I can rewrite this as square root of 3, square root of x to the fourth, square root of x. And so this is square root of 3. The square root of x to the fourth is x squared now, square root of x. And then write this as one square root. So I get x squared, square root of 3x. And so that's the numerator. So I get negative 6 x squared square root of 3x divided by 3x to the fifth. Then we got to reduce. So you see that negative 6 and 3? Let me go ahead and rewrite this over. So you see that that's a 5. So you see that the factor is negative 6 and 3. So you can reduce. So 3 into 3 is 1. 3 into negative 6 is negative 2, isn't it? And then you see you have two factors of x here in the numerator. You have 5 in the denominator, so I can reduce those. So all of these will divide out, and you're left with 3 down here. And so you're going to, now be careful, there's a lot of markings here. So you get negative 2 square root of 3x divided by x cubed. And there's your answer. Now, just to show you, so you may say, well, can't we try doing it the other way? You remember that other way that we did where, let me just kind of remind you, where we had that square root of y cubed, and so we multiply by the square root of y to get the square root of y to the fourth. You can do that. So watch. This is what you would do. So let me go ahead and rewrite this over. And so you have negative 6 divided by the square root of 3x to the fifth. All right, so here's what you're going to do, though. You're going to think, well, what is the, so you see you have a square root, right? And then 5 is not divisible by 2. So that's a little issue. But I know, let me go ahead and rewrite this over. But I know that I can multiply both numerator and denominator by the square root of x, couldn't I? Because x to the fifth times x is x to the sixth. But you got to be careful. There's also this square root of 3 you got to deal with. So you need to multiply by the square root of 3x. So if you multiply both numerator and denominator by the square root of 3x, notice what happens. Negative 6 square root of 3x divided by, and then watch. I'm going to go ahead and actually write it out. So you have a square root. So you multiply in square roots. You're going to write as one square root. 3 times 3 is 9, right? X to the fifth times x is x to the sixth. And then I'll notice the square root of 9 is 3, and the square root of x to the 6 is x cubed. And so the numerator is negative 6 square root of 3x. And then I can reduce the negative 6 into 3. So that becomes negative 2 square root of 3x divided by x cubed, which is the answer we had previously. Just remember, though, you can reduce this. That's 1, and that's negative 2. Okay? And that's it. So that is rationalizing the denominator. Now, one other thing I just got to mention before we go into the next part was this. So in all these problems, I'm going to just go ahead and use this page to show you. In all these problems, notice that the denominator was one term, square root of 12, square root of y, square root of 6. All of them was, they were all just one term, square root of 3, square root of 10, square root of 5, right? Okay, so keep that in mind. All right, so that is the end of this review on rationalizing the denominator when you just have one term.